Alright, so good morning, everyone. So today we're going to discuss another example for the design of doubly reinforced beam. So last meeting, discuss na po natin, introduce natin how to design a doubly reinforced beam. So we will have another example for doubly or design of doubly reinforced beam. So as you can see here, we have here the given for our problem. Yeah, so we have the given here. Of course, the dimension of our beam. We have the width, 310. And then we have the depth. So that is equal to 460 for the depth. And then, of course, we have the given loadings to be resisted by our doubly reinforced beam. That is MD, moment dead load, 230. And then, of course, we have ML, moment live load or live load moment, 190 kilonewton per meter. Of course, we have the material strength. We have F prime C is equal to 30 megapascal and Fy is equal to 415 megapascal. Of course, we have D prime or the distance of compression bar from the extreme concrete fiber. We have 70 mm if compression bar is necessary. Okay, so we need to check if our design first is a doubly reinforced design. Okay, so as you can see here, we have the diagram for a doubly reinforced beam. Okay, so here we have here the cross section of a doubly reinforced beam given the dimensions, and then of course we have here the diagram. For the first diagram, we have the force diagram of the C1, which is the compressive force of concrete, plus T1. Okay, this is the tensile force of a steel. Okay, so here, as you can see, this is a diagram for a singly reinforced beam, and then we have additional force diagram that is due to decompression force of the compression bar or the compressive force of the compression bar. So that is C2. A C2 is will have a formula of the area of the compression bar AS prime plus the stress of our compression bar Fs prime. And then for C1, of course, this is the force due to concrete or in the concrete. So we have stress 0.85 F prime C times area of the concrete A times B. Okay, and then for T1, so T1 here is area of steel in compression number 1, okay, times Fs or the stress in the steel. And then of course, for T2 is AS2 Fs. Okay, so AS2 times the stress that at the tension, that is Fs. All right. Okay, so here, as you can see, AS now, the area and the tension side or the tension steel area is equal to yung AS1 plus AS2. Okay, so if we combine, so the total tension area is T is equal to T1 plus T2. Okay? Yes. Alright, so let's go to our solution. Okay, number one, we're going to do is for us to solve our MU. So if MU is given, very good. But if not, so we will have to compute it. That is 1.2 from our NCP. 2015, 1.2 dead load plus 1.6 live load. Okay, so moment na yung given. So we can directly substitute the value 230 plus 1.6 times 190. Right, so let's continue. So that is 190 a kilonewton meter. So we'll have an answer of uh, 580. Yeah, so 580 kilonewton meter. Right. So number two. So we will solve our phi m tn. Okay. For us to check if our uh, beam, okay, will be designed as a singly or a doubly reinforced beam. Okay, so CTN muna tayo. That is 3 over 8D. Alright, so 3 over 8D. Okay, so 3 over 8, given yung depth for 16. So we will have an answer of 172.5. Okay, 172.5. Of course, after CTN, we will have ATN. Okay, so ATN will be beta 1 CTN. Okay, so yung beta 1 natin dito, class. So it's not equal to 0.85 because our F prime C is 30 megapascal. So from the formula, beta 1 is equal to, that is 0.85 minus 0.05, if you recall it, over 7, times F prime C minus 28. Okay, so we will have a beta 1 of, yes, it must be less than 0.85, but not, but is greater than 0.65 ang sagot dapat dito. Okay, so that is 0. Compute, F prime C is 30. So we will have 0.836 as our beta 1. So ilagay natin dito 0.836 times CTN. So we have 172.5. We will have an answer of 144.21. So 144.21. Yun po ang magiging ATN po natin. After solving ATN, we will have, or we will now solve M or moment TN. Okay, MTN. Okay, so we will have a formula of 0.90 times moment, nominal moment. For tension control, we have 0.85 F prime C AB times D minus A all over 2. Okay, so 0.90 A times 0.85 times F prime C, 30 times A. Ang A na gagamitin po natin dito will be the ATN. So, 144.21 times B, given po yan, 310. And then, the moment arm, D. So, our D is 460 minus A over 2. That is 144.21 all over 2. So, we will have VMTN of 397.97 okay, kilonewton meter. Okay, yan po ang ating VMTN. Okay, so next, we compare it to our MU. So, MU is 580, our VMTM is 397. So, MU is greater than the VMTN. Okay, therefore, it is a doubly reinforced design. Okay, so it is a doubly reinforced design. So, meaning, okay, from a singly reinforced design, from this, we will be adding additional, okay, nominal moment na makukuha po natin dito sa ating diagram na C2 and T2. Meaning, we will add an additional compression bar. Okay? Yes. So, as you can see, doubly po siya. So, itong whole na figure natin na to, okay, yung cross-section natin, this cross-section or this doubly reinforced beam will resist our MU. Okay, gets? Okay? It will resist our MU. And then, of course, this diagram will resist our MU1. So, ano yung MU1? So, MU1 will be the moment, okay, the allowable moment for a singly reinforced design. Okay, sa ibang book, ang ginagamit nilang MU1 is the MN max or the VMN max. Okay, pero gaya na sabi ko, ang boundary condition natin will be the VMTN. So, itong MU1 na to is the VMTN. Okay? So, ibig sabihin, okay, ang kaya niya lang ikarga, itong unang diagram natin, o kaya niyang i-resist na moment will be the VMTN. Okay? As you can see, na mas malaki yung MU. So, kukulangin pa rin, no? Kukulangin pa rin. So, kukulangin pa rin. So, meaning, we will add an additional resisting moment that is our MU2. Yan na yung dahil dun sa ating compression bar. So, if you're going to add it, okay, MU1 plus MU2, that is equal to the total MU. Okay? Yes. Alright. So, meaning, we will know or we'll get the area of the compression bar, okay, by basing our moment to the MU2. Okay? So, nakabase yung area ng compression bar sa excess ng moment natin or excess moment, okay, na hindi na kayang ikarga ng MU1 po natin. So, bakit kailangan dagdagan? Kasi nga sabi sa code, hindi pwedeng lumagpas po sa ating boundary moment. Okay? So, hindi pwedeng lumagpas sa ating boundary moment. Pag lalagpas kasi, okay, yung boundary moment natin, ang mangyayari, it will become a compression control. Okay? Ayaw natin yun. Magiging over-design po yun. Okay? So, kailangan natin hanggang dito lang muna. No? MU1, kung may sobra sa MU, dagdagan natin ng compression bar. So, magiging doubly reinforced beam. Ganun lang po kasimple. No? So, ngayon, Step number 3 na tayo. Compute lang natin. So, yung MU1 natin, yan na yung VMTN. That is equal to, ilan yun? 397.97. And then, yung ating MU, equal yan sa MU1 plus MU2. Okay? Which is, yung MU1 natin is the 397.97. And then, yung MU2 natin is unknown pa rin yan. Okay? Where our MU here, our MU is equal to, yung given, 580. So, we will get our MU2 as equal to 580. Bawasan lang natin ng MU1. So, we will have an MU2 of 182.03. Okay, so meaning, ito lang po yung magiging, ito na yung additional moment to be resisted by our compression bar. Okay? Yes. Alright. So, next, after getting MU2, check muna natin. No? Check muna natin if mag-yield yung mga bakal natin. So, unang-una, we check our FY. So, ang FY natin, as you recall, or our FS, sorry, FS, meaning the actual stress in our tension steel, Fs, from the formula 600 D minus C all over C. So take note, itong Fs natin will be based alone dun sa ating sa tension bar. Okay? So naka-base siya sa tension bar, and of course, we're going to use the C. Anong C ang gagamitin natin dito? Yung C, yung lumabas na C natin dito sa unang diagram. Okay, so ito yung diagram natin sa una. Ito yung may C. Ito yung height of the actual compression concrete. Okay? Ito yung actual height of our concrete na makikerry ng compression. Okay, yan yung C natin. Of course, our C here will be equal to the CTN. Okay? CTN. Ito na po yun. Yung C dyan, yan yung ating CTN. Kasi nga, yung unang diagram is our VMTN. Okay? So, meaning our Fs here, okay, is the actual stress, okay, in our tension controlled. Okay? So, yung CTN natin, as you recall, class, that is, saan ulit nang galing yan? Dun sa strain na 0.05. Meaning, if we're going to convert that, ang Fs natin dyan is 1,000. Tama? So, dapat 1,000 ito. Okay? So, 600 times D, 460 minus C, 172.5 all over 172.5. So, it is equal to 1,000. So, para sa ibang mga example, ang mga solve nyo automatic, ng stress natin doon is equal to 1,000. Therefore, our tension bar yield. Okay? So, it will yield. Okay, tension still will yield. Yield. Okay? So, check naman natin yung sa compression bar kung mag-yield. If mag-yield. So, from the formula for the compression bar, 600 C minus D prime, okay, all over C. Okay, so we will have 600 times 172, tama? 0.5 minus D prime. Ang D prime natin na given is 70. All over 172.5. So we will have an Fs prime of 356.52. which is less than our Fy. Therefore, the compression a bar will not yield. Hindi po mag-yield yung ating compression bar. Alright. Okay, so next, number 5. So, kunin natin yung ating AS1. So, AS1 here is simply equal to our AS sa tension control or AS-TN. Okay? Equal lang yan. So, from that, we can solve that using the first diagram. So, ang first diagram natin, we will have, okay, C1 is equal to T1 from our first diagram, force diagram, dun sa ating MU1, no? So, we will have this, okay, equation, C1 is equal to T1. So, 0.85 F prime C AB is equal to T1 AS1 Fy. So, bakit Fy ang ginamit natin? Because steel or tension steel will yield. Okay, take note, tension steel will yield. Okay, so 0.85 F prime C is 30 AB. So, ang A na gagamitin natin dito as per the first diagram is the ATN. Okay, so that is 144.21 times 300 for the mid is equal to AS1. Yan yung unknown natin. Times FY 415 po. Alright. Okay. So our AS1. Okay. We will have an answer of 2,746.94. Okay. Millimeter square. Okay. So 0.85 times 30 times 144.21 times 310 is equal to AS1 Fy. That is equal to 415 Fy. So we will have AS1 of 2746.94. Okay? So let me double check. We will have the same answer here. Okay, so 276.939 or that is 94. Okay? So next is after solving AS1, solve na po natin yung AS prime and AS2. Okay? So first we need to get the relationship between these two. Okay? By referring to diagram or force diagram number 2. So that is C2 is equal to T2. Yes, so C2 is equal to T2. So C2 here is the compressive force of the compression bar. So AS prime Fs prime is equal to AS2 Fs. So Fs prime here. So what is our Fs prime? So nag-yield yung compression bar will not yield. So therefore, ilagay lang po natin yung value ng Fs prime. That is 356.52. And then yung AS2 natin will have a stress of, so Fs yield So that is equal to 415. So we will have a relationship of AS prime is equal to 1.164 of AS2. Okay? Or AS2 is equal to AS prime all over 1.164. Okay, so we can now solve either of kahit alin sa dalawang yan, AS prime or AS2. Okay, for this example, i-solve na muna natin yung AS prime. Okay, so solving AS prime. Okay, so as we recall, our MU2 will resist this. Okay, excess moment, yung MU2 natin. Okay, so itong couple natin dito, we will have a couple moment here that is equal to the MU2. Okay, so ang couple moment natin, the formula of couple is, what is the formula of couple moment? M is equal to force times the distance. Okay, so ang force na gagamitin natin because ang kukunin natin is AS prime. So that is C2 po ang gagamitin nating force. So ang MU natin, ang M natin, that's equal to our MU2 is equal to force times distance. Okay, so yung MU2 natin, that is the actual moment, no? Yan yung na-compute natin, factor moment. Therefore, okay, so kailangan nating i-multiply yung kabila ng reduction factor. Okay, for this moment here to become a factor moment or the actual moment, no? Para ma-compare natin. So, lagyan natin yung reduction factor times yung nominal moment. So, what is the nominal moment here? Okay, that is C2 times Fs. C2, okay, yung force na yan, C2 times yung moment arm, D minus D prime. Okay, so MU2 is, what's our MU2? Na-solve natin kanina. 182.03. Okay, so wag nyo kalimutan, meron tayong times 10 raised to 6 times 0.90. Okay, C2 here. What is our C2? Formula, AS prime. Okay, AS prime times Fs prime. Ang Fs prime natin, na-solve natin yan. That is 356.52 times moment arm, D, 460 minus D prime, 70. Okay, so shift solve, we will have AS prime is equal to, what is AS prime class? Pag-solve po. Lang. Saan na yun? Ayan. Okay, so 182.03, okay, multiplied by 10 raised to 6 0.90, okay, times 356.52 times the quantity of 460 minus 70, okay, times yung ating AS prime, then shift solve po natin, no? So lalabas na sagot is 14 is 154.62 mm squared. Okay, and then AS2, from this, no, AS2 is equal to 1454.62 divided by 1.164. So we will have an answer of 1249.67. So our AS here is AS1, the tension steel bar, AS total tension steel bar, AS1 plus AS2. Okay? So that is AS1 is 2746.94 plus 1249.67. We will have an answer of 4201.56. And then for AS prime, then we will have an answer of 1454.62 millimeter square and millimeter square. Okay, so this is our answer.